Hey everyone, we're going to take a look at how proportions can solve problems in the real world for us. They are very, very useful in many different fields of science and even art. My daughter's an artist and she uses proportions to help her sell her paintings. Some people want big paintings and some people want smaller paintings, and so she has to scale the copies of the paintings to be big or small. And that's what Oscar is trying to do here. He wants to make a scale drawing of the Titanic. And he knows it's 883 feet long. So he wants his drawing to be a 1 to 500 scale. How many inches long does his sheet of paper need to be? All right, let's begin with the unknown. That's a good place. And it's right here. How long does the sheet of paper need to be? So let's write that down. X equals the length of the sheet of paper. So one other little detail there is they want in inches. All right. Now, I see another fact we'll need to use. The ship is 800 feet long. And that's a real life value, or real world. Now, there's this thing with the scale. Oscar wants to draw a scale drawing 1 to 500. That's his ratio for scaling the paper to the real life. Now, we need to make sense of this ratio before we can get started. And I must admit, it's a little unfair because it's not clear what are the units. What does the 1 mean? What does the 500 mean? And so we're going to have to do some assumptions and translations and interpretations of it. But for a beginner, it would be more fair if the word problem actually told you what the 1 meant. And it doesn't here, so let's see if we can figure out what would make sense. Now, one important thing about all ratios is it's important to figure out what they represent. And in our situation, we're going to talk about the scale of 1 to 500 as the paper length to the real life length. So I'm making it clear that the 1 is talking about the length of paper, and the 500 is representing how much we can draw on the piece of paper that's real life. So we have that's only part of the Titanic, 500 feet of it. And we're going to put it on one piece of paper here. But what is the length that we're talking about? Now, here's the part that I said wasn't clear. What are the units? It seems like if we were drawing, we would be talking about units of 500 feet. That would be the real life thing that we would like to fit. But the 1, it might be easy to confuse that at first if you don't think about it a little bit. It could be like 1 inch or 1 foot. Now, this is where we have to use some logic and reason it out. 1 inch. Here's 1 inch paper. How good of a drawing can I make 500 feet of the ship on this tiny 1 inch piece of paper? My drawing's going to be terrible. I can't scrunch 500 feet of details from the ship on that piece of paper. But if my drawing is a foot, which is 12 inches, we can draw the ship with a lot more detail here. So I wanted to reason that out, that even though the units aren't there, the most reasonable way of thinking about this is that it's 1 foot of paper length to draw 500 feet of real life ship. So now that we have that clear, I think we can start solving. Okay, so I want to write an equation for x. And I know this part of the equation, 1 over 500 equals. Now I need the other ratio. Now the big question I would ask you in the second ratio is x on the top or the bottom. So I wrote down 2 equations here for us. 1 over 500 equals x over 883, and 1 over 500 equals 883 over x. Both of these are proportions, but one of them is the wrong equation. And it's very easy to make this mistake if you're not forcing your mind to think clearly about what the ratio means. And we did that already. We decided ahead of time that the ratio means the paper length on top and the real life length on the bottom. And so you can deduce here one of these equations is wrong because my second fraction is flipped upside down. If you look at this one, the 500 is the real life. And when I put x on the bottom, I'm putting the paper length and the real life on top. And the 1 we said was for the length of paper. So can you see that the fractions don't match up top to top? The first one is paper on top and the second one is real life on the top. The bottom is real life on the bottom and paper length on the bottom. They're not matching up. The blue one is incorrect. I had this fraction upside down and it's throwing off the equation. It's going to give me a completely wrong answer. But if we look at the first one, the 1 we said was paper length. And what is x? X is the length of paper. So the top matches with the top. And the 500 is feet of real life ship, and the 883 is feet of the real life ship. So now we're seeing everything matched up. So the black equation is the correct one. And we had to take a minute to clarify that. And that was an easy problem to prevent, as long as you make sure that before you begin in your head, you know what is the top and what is the bottom. You should do that with every proportion equation. Write it in words so you don't accidentally get the equation with one fraction upside down. But with that now, we're ready to solve. So I'm going to cross multiply. We got 500x on the left, equals in the middle. Cross multiply on the other side, got 883 on the right side. Now remember, all these numbers are in feet. Now I said that x is in feet because it represents the top. So technically it says inches here, but it's not inches. The scale is 1 foot to 500 feet. So when we solve this, we're getting everything measured in feet. Now you have to probably do that in a calculator, and it turns out to be 1.76 feet. Because the scale was in feet, this X answer has to be in feet. But that tells us that Oscar's paper has to be 1.76 feet long. So our scale was 1 foot to 500 feet, which forced our X to be an answer in feet. And now we do have the X answer, but it's not quite finished because how many inches of paper is this? So we have to do another little bit of math conversion here, and that's easy to do because we know that there are 12 inches in a foot. So there's a ratio. We can make a unit conversion. That's another ratio. But when we have feet on the bottom, they cancel those feet on top. And so simply stated, we just multiply 1.76 times 12. And when we do that, we're going to get 21.12 inches. So that's the length of Oscar's paper in inches. Okay, let's take a look at another one. Here's another application of proportions to the real world in the area of medicine and nursing. So you've seen part of this problem with me in class when we wrote a ratio, but I added more to the problem that's going to require some algebra and some solving. Okay, a nurse's duty is to mix medication in proper proportions for each patient. For one patient, you always mix medicine A with medicine B in the same proportion. Last week, the doctor indicated that you should mix 40 milligrams of medicine A with 16 milligrams of medicine B. However, there's the new part. This week, the doctor said to only use 4 milligrams of medicine B. How many milligrams of medicine A should we use? Okay, so right there is our question. How many milligrams of medicine A? Let's call that X. Milligrams of med A. We are comparing two things. We're comparing 40 milligrams to 16 milligrams. How should we write the comparison? Well, the comparison should be a ratio. Now, there's a little bit of flexibility here on your ratio. But let's make sure that we're going to keep everything in order by figuring out our ratio. Let's let the ratio be medicine A on top and medicine B on the bottom. Now we're going to write an equation, and we need this to make sure we keep both sides of the equation with the correct ratios. Because if you're not thinking that clearly, you might have one ratio one way and the other side of it flipped upside down, and it'll give you the wrong answer. So let's see if we can create an equation to solve here. So I see 40. Now, does that go on the top or the bottom? It's 40 milligrams of A, so that's going to be on the top. And I have the 16. Is that on the top or the bottom? Well, that's medicine B, so I'm putting medicine B on the bottom. There's my ratio of A to B. Now that has to be equal to, that was last week. Now last week needs to be proportional to this week. And so the doctor is making a change, and he says, okay, wait a minute, this week you're going to use 4 milligrams of medicine B. Now, if we were able to talk about this in class, I would ask you, does 4 go on top or bottom? You have to be really clear with that. If you get that backwards, it'll ruin the whole outcome. Okay, now the 4 milligrams is a medicine B, and we established back at the beginning that medicine B has to go on the bottom. Now we could ask the same question about X. Does X go on the top or the bottom? Well, for this week, X is medicine A. A is always going on the top. So X has to be on the top because it represents medicine A. So on the left, we have last week. And on the right, we have this week. So last week has to be proportional to this week. And as long as you've got both fractions with A's on the top, B's on the bottom, you have made a correct proportion equation. Okay, so now I'm going to erase my scratch work over here, and we're ready to solve. Let's cross multiply. 16 times x, I'm going to put that on the left, equals in the middle, cross the other multiplication. 40 times 4 is 160. And we've got a simple equation now. Let's divide by 16 on both sides, and we will get our x answer. X equals 10. But don't stop there. 10 what? What does 10 mean? It means 10 milligrams of medicine A. There we found the solution for the medicine that the nurse has to administer. She has to give 10 milligrams of medicine A and 4 milligrams of medicine B. Let's try another one of these. All right, here's another example where we're talking about statistics. Now, these statistics can be statistics about health, like this problem is Alzheimer's, but it could be about crime. It could be about voting statistics. All kinds of things are relevant here for proportions to solve real-world problems. Let's take a look at this one. In the United Kingdom, Alzheimer's disease is said to affect 1 in 50 people who are over age 65. If approximately 250,000 people over 65 are affected with Alzheimer's, how many people over 65 are there in total? There is a question here. How many? So, let's let X equal the number of people who are over 65. So X is representing like the whole group. So I knew that I'm talking about the whole group because of that word there, total. They're just saying everybody together. Now there's another number here that's important, is the 250,000. And these are the people who are affected with Alzheimer's. So we have a certain group. We have a certain group in that population that has Alzheimer's, and they told us that it's about 250,000 people. Okay, now there's one more fact here. There is a ratio, a comparing of two things, 1 in 50. Okay, so we have a ratio 1 in 50. Now this is much better than the problem about Oscar because the 1 is much more obvious. We're talking about 1 person in 50 people getting Alzheimer's. So what's going on here? Now we still need to understand what does the 1 mean? And the 1 on top is the number of people with Alzheimer's, and the 50 on the bottom is out of 50 in the whole group. So you can see here over on the bottom, I wrote down what the fraction means, what the ratio means. It means 1 person has Alzheimer's out of a group of 50. So if you went to the United Kingdom and you had a meeting with 6 people who are over the age of 65, and there were 50 of them in the room, that's the whole group, 1 of them is going to have Alzheimer's. That's what this statistic is telling us. If I said in our class 1 in 7 people would get COVID, well, we have a class of 7, so that means 1 of the people in the class would get COVID. Now, hopefully that doesn't happen. It won't happen. We'll take care of ourselves. But I'm just trying to illustrate the idea of 1 in 7 or 1 in 50. The 50 or the 7 is the whole thing, and the 1 is, of course, the 1 person who is different than the rest. Now we have this ratio 1 in 50. It allows us to solve equations and make conclusions on bigger populations. So I want to solve an equation for X, and I'm going to start with the 1 in 50 to make my equation. So remember, 1 is the people who have the disease Alzheimer's, and the 50 is the whole group. Now that's got to equal a fraction. And I've decided that the whole is the bottom number, and the number of Alzheimer's people is the top number. So now my question to you is, where does X go? Top or bottom? Make a thoughtful, clear decision here. X represents the number of people over 65. It is the whole group. Oh wait, so that's telling us that X should go on the bottom. Let's double check that with the other number. What is the 250,000? Just in case I was wrong, I'm going to rethink it. Top or bottom? What is 250,000? That's the number of people with Alzheimer's. That's got to be the top. So when we make our second proportion, the X is on the bottom because it's the number of people in the whole group, and the 250 is the number of people with Alzheimer's. So this is the important thought. You just be careful with how you decide how to set up your ratio. But once you've done that, it's easy to solve. Let's do x by itself by cross multiplying. So 1 times x and 50 times 250,000. 1 times x is 1x. I don't really need to write the 1 anymore because 1 times x is just x. Equals in the middle, and then 500 times 25,000. I'm sorry, I said it wrong. 250,000, and we get 1, 2, 5. 1, 1, 2, 3. So we get this big number, 1,250,000 what? What does that big number mean? It's people, of course, but what is special about these people? It is the number of people over 65 in the UK. So they have 1,250,000 people over 65 in the UK. Out of that 1 million something, we know that some of them are sick. The 250,000 have Alzheimer's. There we go. There is the solution to that problem right there. Keep practicing with these. Study hard.